Well, hi there, everybody out there in YouTube land. Welcome back to Kramer's Garage. This is Bob Kramer. Let me show you what I've got going for you today. In my last video, I showed you why I was removing the NWT Cycletronic X3 system from my bike. So I completely removed that, along with their switches and everything. And I've just completed rewiring the bike. So let me show you what I did. I don't have everything completely back together yet, but anyway, let's start from the back. I'm still using the same start solenoid that I had before, which is a modern type of solenoid with the built-in main fuse. I currently have an amp meter plugged in there to measure the current on the bike. Okay, and then down here I've plugged in a voltmeter. My voltmeter is up here. You can see 12.5 volts. I'm going to mount this voltmeter inside the side shelter cover. So anyway, and this is my regulator rectifier, and this unit is from NWT Cycletronics. I didn't change that out, and that's a digital regulator rectifier that works on pulse width modulation. So because it's not shunting the excess voltage through resistors, it does not get very hot. So heat buildup is not really a problem with that. Okay, so let's move forward. I really like using lever locks. You have to connect your wires somehow. So I like the lever locks. And I've built this panel, and virtually all the connections are on this panel. When they wire the bike in the factory, they have connections all over the place on the bike. They crimp wires together inside the wire loom. I don't like to do that. I don't have any connections that are buried in the wire loom. Everything is right here on this panel. Easy to troubleshoot. Also, these lever locks, each one of them has a hole where you can stick a voltmeter in. So if you're troubleshooting, you can just put a voltmeter right in the hole there and check voltage at each one of these connections. And then the signal dynamics unit here, this is their advanced turn signal module, and that gives you a true self-canceling turn signal system, which is awesome. I've used Signal Dynamics turn signal modules on other bikes in the past, and they work really well, and they've withstood the test of time. I did a bike about 8 years ago, the first time with Signal Dynamics, and it's still functioning perfectly 8 years later. So that's withstood the test of time, and I'm very confident that this will work very well for many years. If there's one fault with Signal Dynamics, it's the length of their wire leads. So the leads are all permanently potted into the unit, and they're only about 4 inches long. So I put a terminal block next to it, and I run the wires from the Signal Dynamics unit to a terminal block, and then connect it to all the circuits through the terminal block. Going to the back turn signal, I used a lever lock here going to the back turn signal. And then coming forward, I bought a fuse box that has 4 circuits, and it has a main relay built in. So my ignition key switch, turns on the main relay. So none of the power to power the bike is actually going through the key switch. The only thing going through the key switch is the power to energize the main relay, and it's a 20 amp relay built into this. And so then I ran 4 circuits out of there to run everything else on the bike. Let me turn it on and show you what it does. So there's blue LEDs here. The blue LEDs light up when you turn on the power. If a fuse blows, the LED will turn red. So that's pretty handy from a troubleshooting standpoint. Now, I stuck an H4 light bulb in here. This is a temporary, just for test purposes only. So you can see my headlight works. There's high beam, low beam, high beam. Now you'll also notice my turn signals are also functioning as position lights or marker lights, front and back. And I've put red LED light bulbs in the back and in the tail light as well. So let's there's the brake. Have I got it in the picture? Oh, I don't have it in the picture. Wait a minute. Brake light. And my turn signals are also functioning as brake lights. Okay. Now, we said that we have a true self-canceling turn signal system. So to really have a self-canceling turn signal system, it's good to have a momentary contact on your turn signal switch. So I'm using the original Honda 1977 Honda turn signal switch, and I discovered that if you don't push it all the way, it doesn't latch. So you can see I'm flashing now. Turn signal is on, and if you push less than 1 second, it flashes for about 7 seconds, and then self-cancels. Now, if you hold it more than 1 second, it'll flash for 20 seconds and then cancel. And this is a true self-canceling turn signal system because also if I pull the brake, let's see if that's gonna, there we go, it just canceled. If I hit this and then I pull the brake, that'll continue to flash until I release the brake, and then it'll cancel in 10 seconds. So I'm holding the brake, and my turn signal continues to flash. Now I'm going to release the brake. 1001, 1002, 1003, 1004, 1005, 1006, there we go. I released the brake and it canceled. So if you're sitting at a traffic light, you just hold your brake and your turn signal stays on. When you release the brake, it'll cancel. I used an aftermarket switch on the right-hand side because the original Honda switch did not have a switch for hazard lights. This aftermarket switch does have a hazard light switch. To make this compatible with the signal dynamics unit, I have to turn it on and then off, and incidentally this is marked wrong. The on, where it says on here, is actually off, and vice versa. So I'm going to have to black that out and change the labeling on there. But anyway, to turn on the hazard lights, signal dynamics instructions say to press both buttons, left and right, simultaneously for 1 second. So this switch actually shorts the turn signal switch with a 3-way contact. So if I just turn this on and off for 1 second, it'll turn on the hazards. So watch this. There. I now have 4-way flashers, hazard lights. And let's see what it looks like in the back. I'm going to turn off the lights and see what it looks like in the dark. Yeah, that's pretty darn good in my book. Okay, to turn it off, just repeat the process, on and then off, and now they're off. And we're back to normal turn signal functioning. Yep. Okay. Yeah, I like it. All right, now let's look at the current consumption. So with all the lights on, headlight and everything, I'm drawing 8 amps. The headlight is drawing about 5 amps because it's an H4 bulb. I will probably eventually change that to an LED, which will draw probably half of that. So 8 amps. When the bike is running, it only goes up to about 9 amps. And when the fan kicks in, it goes up to about 12. So the most this draws when it's running and the cooling fan kicks in and everything, the most this draws is about 12 amps. So I'm perfectly comfortable to put a 20 amp main fuse in, and that will protect my main relay and my fuse box, which is rated for 20 amps. And my fan, incidentally, I did not put the fan through the fuse box. The fan is connected directly to the main fuse. So if the fan shorts out, it'll blow the main fuse. And I may change that. I may put a 10 amp fuse or something on the fan, but for now, the fan is connected to the main fuse. But anyway, okay, and then let's move forward and look at one other thing. If you've worked on these Honda motorcycles very much, you've experienced a big ball of bullet connectors. And that's when Honda wires these Gold Wings, they put a big ball of bullet connectors right here that connects all the control wiring. Instead of that, I put a terminal block here, 6 terminals, and the ones that required connections here are on the terminal block. Now, this is my clutch wire and this is my neutral wire. I may later on put a diode there. Right now, the way it is right now, you have to pull the clutch in to start the engine, even in neutral. But once I verify that my neutral switch is functioning correctly, which I'm not sure it is right now, once I verify that, then I'll put a diode across here so that it will be able to start in neutral without pulling the clutch. And that's another thing. This type of wiring, the way I do it, it makes it very easy to make modifications or changes. I'll show you what the diode I put in for the taillight. So Honda originally had the parking light wire basically going through 2 contacts in the ignition switch, one contact to turn it on and another contact to disconnect it from the rest of the circuit, because of course when you turn on the tail light alone, the tail light is wired in with the rest of the lighting circuit. So what I did is I put a diode here, and that diode is between the tail light and the rest of the lighting circuit, so that when you turn on the lighting circuit, turn the ignition key on, the electricity goes through the diode this way and lights the tail light. When you have the key in the park position, the rest of the lighting circuit is turned off, the tail light is turned on, and there's no feedback going to the rest of the system because the diode is blocking it. So a diode blocks current in one direction and allows current in the other direction. So that eliminates the need for that extra pair of contacts in the ignition switch, and it makes the wiring a little bit less complicated. Now let's move around to the headlight bucket. The headlight bucket, as you can see, it's got a Molex connector here for the dash panel. So this has all the wiring for the dash panel in this Molex connector, nine pins in the Molex. Now I've used several of these lever locks to connect the turn signals, headlight, various functions. Now you can see these are very convenient to label. So I've labeled some of them. Left there, this one you can see is the connection for the starter and the ignition coils. So that's coming from the kill switch. But anyway, so these will lay pretty flat in here, and I might put some Velcro on these and stick them to the headlight bucket like that, so they'll lay flat in there, making it easier to take the headlight in and out. This lever lock will be connected to the actual headlight. Right now it's just a temporary, I just put a temporary socket in there for test purposes. But the next thing I'm going to do is put the headlight in, of course, and get everything all buttoned up here. So that's my wiring system. Let's take a look at the drawings. So this is the drawing that came from Signal Dynamics, and this is the actual drawing for wiring that Signal Dynamics unit into the turn signals. This is the schematic that I created for the entire bike. So that's it. If you want to study my schematic, you can pause the video and study it to your heart's content. I don't have it copyrighted. But anyway, in this schematic, I actually corrected some problems that Honda had built into the original wiring. So I corrected a few problems with the original wiring. I modernized it a little bit. I updated it. I streamlined it somewhat. And I made a ladder diagram format schematic that's much easier to read and understand than the schematics that motorcycle manufacturers typically publish. All right, well, I think that's it. So everything works now. I think I showed you everything working. Everything works now as it should. Brake lights work. Everything is working. So I'm going to end this video now, and yeah, comment, give me some comments. Let me know what you think about my electrical system. I kind of like it. I really like what I did here. I've got everything loomed up real nice. I'm thinking about putting better bags on this bike, which will require me to relocate these turn signals. And I have this all loomed up real nice, so I may wind up having to cut that one apart and redo it. But that's not the end of the world. So anyway, if you like my video, subscribe to my channel. Thanks for watching.